Next story. UK boosts global efforts to digitize natural history collections. In a remarkable stride towards unlocking the secrets hidden within natural history collections, the United Kingdom has announced a groundbreaking initiative to digitize its vast array of specimens. With a generous funding of £155 million over the next decade directed at the Natural History Museum, NHM, in London, this endeavour marks a pivotal moment that could revolutionise scientific research. The ambition behind this project is nothing short of extraordinary: to digitize millions of specimens, ranging from ancient rocks and fossils to pressed plants and pinned insects, and make them accessible to researchers worldwide. This digital transformation is not merely about cataloguing data. It aims to weave a narrative that connects the past, present, and future of our planet, offering invaluable insights into evolution, biodiversity, and environmental resilience. Helen Hardy, leading the digitization efforts at NHM, expresses her enthusiasm for the funding that promises to propel their initiatives to new heights. The UK Research and Innovations Pledge serves as a testament to the crucial role natural history collections play in shaping our understanding of the world. By converting specimen details into digital records and high-resolution images, researchers hope to create immersive experiences that transcend traditional boundaries of exploration. The implications of this initiative extend beyond the borders of the UK, potentially catalyzing similar endeavors in Europe and beyond. The collaborative spirit driving projects like the Distributed System of Scientific Collections, DISCO, underscores the global significance of digitizing natural history collections. As Vincent Smith, a key figure in the DISCO initiative, points out, the impact of such efforts transcends scientific realms, spurring innovations in data management, AI applications, and robotics. While the UK takes a giant leap forward in digitization, concerns linger about the US lagging behind in this transformative journey. The absence of substantial funding allocations for digitization efforts in the US raises doubts about the country's role in shaping the future of natural history research. Scientists like Gil Nelson emphasize the necessity of leveraging existing momentum to ensure that previous efforts do not languish in the shadows of missed opportunities. The urgency to embrace digitization as a cornerstone of scientific progress reverberates across the scientific community. With advancements in technology shrinking the timescales and costs associated with digitization, the prospect of creating a vast digital repository of biological specimens becomes more achievable than ever before. The potential to harness AI, computer vision, and other cutting-edge tools offers a tantalizing glimpse into a future where scientific knowledge is accessible at an unprecedented scale. As the UK embarks on this transformative journey, the global scientific community watches with bated breath, eager to witness the cascading effects of this monumental endeavor. The digitization of natural history collections symbolizes a paradigm shift in scientific exploration, where the past converges with the present to illuminate the path forward towards a more profound understanding of our world. Source: Science Magazine, www.science.org. Next story. Warning: global population tipping point looms by 2030. In a world where numbers have the power to shape our future, the magic number of 2.1 has emerged as a pivotal figure that could determine the fate of human population growth. The concept of replacement fertility, where each person gives birth to enough children to sustain the population, has long been a topic of interest for demographers. However, a recent study published in The Lancet has sent shockwaves through the scientific community by predicting that the global population could reach a tipping point as soon as 2030. Factors such as increased education levels, rising incomes, and better access to contraceptives have contributed to a decline in fertility rates in many countries. The United States, China, and Taiwan are just a few examples of nations where fertility rates have fallen below the critical threshold. While previous estimates suggested a later timeline for reaching this population tipping point, the new study's lead author, Christopher Murray, warns that fertility is dropping faster than anticipated, leading to a potentially accelerated timeline towards the 2.1 threshold. The implications of falling below replacement fertility are profound, with the potential for a global population decrease looming on the horizon. However, this decline is not expected to happen overnight and could take roughly 3 decades for the death rate to surpass the birth rate. This shift towards a lower fertility rate could result in a world divided between low fertility countries grappling with an aging population and high fertility countries facing challenges of sustainable development. Predicting when this turning point will occur is no easy task, with various models offering different timelines based on fertility data and trends. The study from the Institute for Health Metrics and Evaluation, IHME, takes into account factors such as access to contraceptives and education levels among parents, which could influence fertility rates. The potential disparities arising from varying fertility levels could have far-reaching consequences, from labor shortages in high-income countries to economic stagnation in low-income nations with high fertility rates. While some experts remain cautiously optimistic, others emphasize the urgency of addressing these population trends sooner rather than later. The looming prospect of a population tipping point by 2030 serves as a stark reminder of the complex interplay between demographics, economics, and social development on a global scale. As we stand on the brink of a potential shift in human population dynamics, the need for proactive solutions to navigate this uncharted territory becomes increasingly apparent. Source: www.science.org. Next story. Bird flu spreading. U.S. dairy worker infected. Cows affected in multiple states. In a recent turn of events that highlights the interconnectedness of the natural world, a U.S. dairy farm worker has been infected with a bird influenza virus that has now spread to cows in 5 states. This alarming development has raised concerns among scientists regarding the potential evolution of the virus to become more transmissible between people. The strain in question, a subtype of H5N1 known as clade 2.3.4.4b, has been wreaking havoc on wild birds and poultry for over 2 years. Now, with its appearance in mammals, there is a renewed sense of urgency to understand the extent of its spread among U.S. cows and to prevent further infections in both herds and humans. As scientists grapple with the implications of this emerging situation, another revelation has come to light in the field of evolutionary biology. A recent study published in the Proceedings of the National Academy of Sciences has unveiled how a rogue segment of DNA has disrupted the bird family tree, leading to a re-evaluation of avian evolution. This discovery has reshaped our understanding of the ancestry and relationships among modern bird species, highlighting the importance of genetic analysis in uncovering hidden evolutionary patterns. In the realm of archaeology, a surprising find in Germany has challenged conventional notions of early human toolmaking. Spears, throwing sticks, and other wooden artifacts dating back 300,000 years have been unearthed near a coal mine site, shedding light on the sophisticated craftsmanship of ancient hominins, likely Neanderthals. This discovery underscores the complexity of Neanderthal behavior and the diverse range of tools they utilized in their daily lives, offering a glimpse into their ingenuity and resourcefulness. Shifting gears to the realm of drug discovery, researchers have made a groundbreaking discovery that could revolutionize the fight against antibiotic-resistant bacteria. By testing thousands of non-antibiotic drugs for their antibacterial properties, scientists have identified nearly 200 compounds capable of killing E. coli bacteria through unique mechanisms. These findings suggest a potential treasure trove of new antibiotic candidates hiding in plain sight, derived from drugs originally designed for different medical conditions. In a fascinating study published in Science Translational Medicine, researchers have uncovered a link between a gut bacterium, Akkermansia mucinifila, and a chronic autoimmune kidney disease known as IgA nephropathy. The study highlights how a normally beneficial microbe can trigger illness by converting antibodies in the gut, ultimately leading to kidney inflammation. This discovery sheds light on the intricate interplay between gut microbes and autoimmune diseases, offering new insights into the mechanisms underlying acquired autoimmune conditions. As the scientific community delves deeper into these diverse realms of inquiry, each new revelation brings us closer to unraveling the mysteries of the natural world and harnessing its potential for the betterment of human health and understanding. Source: Science Advisor. U.S. dairy farm worker infected as bird flu spreads to cows in 5 states. www.science.org.